This is Algebra 2, spring test number 3. We're in week 3 study guide. Number 1, we are simplifying a rational expression. You're going to take the numerator. You're going to make the trinomial into two binomials. So maybe you could treat the z squared as if it's x squared. You're going to make two binomials on the top. Z times z is z squared. And then remember, you want to factor out the c variable, or the c number, 8. In order to factor out 8, you can do 1 times 8 or 2 times 4. You want the pair of those numbers that's going to give you 2 in the middle. 1 and 8 is only going to give you 7 or 9. 2 and 4 is what you have to use. So 2 and 4. Look at your sign in front of C. It's negative. That tells you that they're going to be opposite signs. And this one tells you since they're opposite, the bigger one, the larger one, or the one with the higher absolute value is negative. So 4 is the bigger absolute value. It's negative. 2 is positive. The bottom, we're going to do the same thing. We'll factor it out. Again, z times z will give us z squared. Now we're going to factor out the new c value, 16, 1 and 16, 2 and 8, and then 4 and 4. So which pair of those will get you to b's value, 10? The only pair, this will get you to 15 or 17. This will get you to 8 or 0. It has to be 2 and 8. This sign right here tells you that they're the same. This sign says since they're the same, they're both plus. So you have z plus 2 is exactly the same at the top and the bottom. You cancel it out, and you're left with z minus 4 over z plus 8. Same thing with this one. We try to go a little bit quicker with this one. You have k times k to give you k squared. 56 is 1 in 56. I said 1 in 56 and over 52. 1 in 56. 2 and 28. Okay. 3 is not going to go into it. 4 is going to go into it. It's going to go into 5 one time, so it'll be 14 times. 5 doesn't go into it, 6 doesn't, and then 7 and 8. 7 times 8. So which pair of those gets you to your b value of 1? The only pair that'll get you there is 7 and 8. The rest of them are too far apart. So you're going to use 7 and 8. This sign tells you they're opposite. This sign tells you since they're opposite, the bigger one's plus. 8 is bigger. It's plus. 7 is minus. You're going to do the same thing at the bottom. Same thing at the bottom. K times k. Your factors of 35, 1 and 35. It's odd, so it's not 2 times anything. 3 times, nothing goes into 35. Neither does 4. 5 times 7 is 35. So you have to use one of those pairs. The only one that gets you to b value 12 is 5 and 7. This sign right here tells you they're the same sign. This tells you they're both minus. So minus 5, minus 7. You can see what's that exact same thing at the top and the bottom. Negative minus 7, minus 7. You're left with k plus 8 over k minus 5. Okay, for number 3, we're multiplying and dividing these. 8x cubed over 4y to the 5th times 5y to the 6th, 3x to the 6th. Remember, anytime you can cancel something out, you want to. So just first looking at it, we can cancel out 8 and 4. The number 4 goes into both of those. It goes into itself once, and it goes into 8 twice. So we create 2 right there. We can do the same thing with our x's. We can cancel those out. X to the 3rd will cancel out, and it's going to cancel out x to the 6th. It'll leave us with x to the 3rd right there. We can do the same thing with our y's. Canceling out the y's. Y to the 6th will get canceled out. Y to the, what you're left with is you look something that looks like this. Y to the 6th over y to the 5th. Since they're the same base as y, you subtract the exponent. 6 minus 5 leaves you with y to the 1st power at the top. So when you cancel these out, it leaves you with y to the 1st power. So now all you do is multiply straight across to see what you get. 2 times 5 is going to be 10, and there's one y still up there. And then the only number at the bottom, the only coefficient is 3, so there's nothing to multiply 3 by. X is to the 3rd power, And we canceled out, I forgot to scratch it out, we canceled out this y to the 5th to get rid of that y to the 6th on the top. 10y over 3x to the 3rd. C squared over c minus 4 times c squared minus 5c plus 4 over c squared plus 6c. What you want to do is you want to take out and factor things out. Once things are factored out, you can see what you can undo. You have c squared over c minus 4. You can't take away that c squared over c because it's subtracting 4. We can factor out the other fraction, though. We can make a trinomial into two binomials, c times c. Your factors of 4 are 2 and 2 and 1 and 4. That's the ones we got to use, 1 and 4. This says they're the same sign. This says they're both minus. Minus 1, minus 4. Over, we can take a c out of the bottom. C times c plus 6. Now we can eliminate some stuff. C minus 4 is exactly the same on the bottom and the top. That'll cancel out. And we have c squared over c to the first power. We could eliminate c to the first power and eliminate c squared. That's just like doing this. C squared over c. That gives you c to the 2 minus 1, which is c to the first power. So now see what you still have on the top. You have a c. It's multiplying by c minus 1. And on the bottom, you still have c plus 6. Number 5, m plus 1 over m plus 5. We can't do anything to factor any of those out, and they don't cancel each other out. Okay. What we want to do, though, since it's dividing this time, we want to change it to multiplication, and we want to multiply by the reciprocal. The reciprocal means we're going to put what's on the bottom on the top. So that trinomial m squared plus 7m plus 10, we're going to make it into two binomials, m times m. Your factors of 10 are 1 and 10 and 2 and 5. That's what we need to use, 2 and 5 to get to 7. This says same sign. This says both plus. Plus 2, plus 5. On the bottom, we'll bring down what they have on the top, m plus 4. From there, we'll cancel out everything that's exactly the same. M plus 5 is exactly the same over m plus 5. So what we have is m plus 1 times m plus 2 over m plus 4. Number 6, least common multiple of each of these trinomials. You want to make trinomials into two binomials. So x times x gives you x squared. Again, your factors of 6 are 1 and 6 and 2 and 3. Which one of those pairs gets you the b's value? 7 has to be 1 and 6. This sign says they're the same. This sign says they're both minus. Minus 1, minus 6. We're going to do the same thing with this one over here. X times x. There's only one set of factors for 3, 1 and 3. We have to use those. This sign says the same. This sign says both minus. Minus 1, minus 3. So what you want to do to make an LCM, or least common multiple, is you want to make sure everything's represented. We have to represent x minus 1 and x minus 6. Now, when you look at the other side, when you look at this one here, x minus 1 is already represented. We don't have to do it again. You need to represent the x minus 3, though, and that gives you the least common multiple, x minus 1 times x minus 6 times x minus 3. Number 7, again, least common multiple. We're going to factor out this. Okay, again, number 7, I actually messed up with this one, let this one go. I meant to take it off, just like I meant to take it off last week. It really is as easy as taking an x out of the first 3 and creating a trinomial that way. But we hadn't really gone over any like that, so you can do that when there's bonus, and you can ask me about it tomorrow. Number 8, we're adding or subtracting. We're simplifying if possible. In order to add or subtract fractions, the bottom number, the denominator, has to be the same. So what you want to do is make sure everything's factored. 8 over c minus 10, we can't do anything with that, plus 2 over. Now you have the difference of two perfect squares. You can take the square root of c squared and get c, and the square root of 100 and get 10. Remember, the difference of two perfect squares means it's going to be c plus 10 and c minus 10. So what you need to do with this one is you need to make sure that everything at the bottom of each of these fractions is represented. We need to make sure the denominator represents c minus 10 and what's in the other fraction, c plus 10. Notice c minus 10, we already have it represented. We don't have to write it again. So the denominator of this fraction is going to be c minus 10 times c plus 10. From there, you want to take that denominator and try to eliminate everything you can, just like when we try to eliminate fractions. So multiply the first fraction times c minus 10 times c plus 10, and multiply the second fraction times c minus 10, c plus 10. We're going to cancel out. This one says c minus 10 is exactly the same as c minus 10. So we're left with in the first fraction is 8 times c plus 10. Then we have plus, eliminate what's the same on the other side. C minus 10 is exactly like c minus 10. C plus 10 is exactly like c plus 10. So what's left on the other side is 2. Simplify this by distributing 8 times c is 8c. 8 times 10 is plus 80. And then you have plus 2. So when you simplify that, just combine your like terms, 80 and 2, and you get 8c plus 82 over the denominator c minus 10 times c plus 10. Number 9, we're doing the same thing. Just notice it says minus instead of plus. Factor out the first one. We just got a little more factoring to do with this one. N times n. Your factors of 8 are 1 and 8 and 2 and 4. You have to use 1 and 8 to get to 7. This says they're different signs. This says the bigger one's plus. 8 is bigger. 1 is smaller. Minus 1 plus 8. Over the bottom, we're going to do the same thing. We're going to make two binomials, n times n. Factors of 1 have to be 1 and 1. Same sign, both minus. Minus 1, minus 1. Okay. Then it says minus, and then the right fraction says 6 over n minus 1. Now, unlike multiplication and division where you can cancel out something in this fraction with something in this fraction, we can't do that with this one. However, we can cancel out two things that are the same in the same fraction. So if you notice, n minus 1 is the exact same thing as n minus 1. So now what we're dealing with is n plus 8 over n minus 1 minus 6 over n minus 1. Now you have the same exact denominator for both of them. They both say n minus 1. So that's going to be your denominator. And then you treat it like, exactly like rational expressions that have the same denominator. You just simply subtract the top, n minus 8, the numerator, minus the top of the other one, 6. And when you put 8 minus 6 together, it leaves you with n plus 2 over n minus 1. Number 10, we're doing the same thing. You're going to factor out the trinomial on the top. K times k is k squared. Your factors of 12 are 1 and 12, 2 and 6, and 3 and 4. You know, the only one to get to 1 is going to be to use 3 and 4. I wrote them backwards. Different signs, bigger one's minus. 4 is bigger, 3 is positive. Over, factor out the bottom trinomial, k times k. Your factors of 8 are 1 and 8 and 2 and 4. The only way to get to 2 is to use 2 and 4. Again, different signs, bigger one's minus. Minus 4 plus 2. Okay, so then we have plus 10 over k plus 2. Again, you can cancel out in the same fraction, k minus 4 over k minus 4. So now we have the exact same denominator, k plus 2, for both of them. So k plus 2 is your denominator, and on the top of the one on the left, you have k plus 3, plus on top of the one on the right, you have 10. And when you simplify 3 plus 10, you get k plus 13 over 2. I'm sorry, over k plus 2. Number 11, now we're going backwards a little bit, factor in the expression. You want to factor your C value 56. Remember, 1 and 56, 2 and 28, and 4 and 14. Yeah, 4 and 14. Which and 7 and 8. Which pair gets you to 15 though? That's what's important. 7 and 8 is the only pair that gets you there. This sign says they're the same signs. This sign says they're both plus. So x plus 7, x plus 8. Number 12, solve the equation, check your solution. Undo your order of operations. Please excuse my dear Aunt Sally is the way you still do it, but you're going to go this way. You look for addition and subtraction first. We have that. We have minus 6, so you add 6. If you add it there, add it here. Negative 1 plus 6 is positive 5 equals the square root of x. We don't have anything multiplying, so we can go past that next step. The next step is exponents and radicals. We have a radical. We have the square root of x. In order to cancel out the square root of x, you square that side. If you square it, you have to do the same to the other side. 5 squared is 25. This cancels out, so x's value is 25. Check your solution. When you plug it back into the original equation, negative 1 equals the square root of 25 minus 6. We know the square root of 25 is 5 minus 6, and that is negative 1. That's a true statement. Solve the equation. Look for identify any extraneous solutions. Again, this acts like a parentheses, this symbol. It acts like a grouping symbol. So you can't undo plus 35. You have to undo the square root by squaring it. If you do it there, do it here. What you have now is x squared equals 2x plus 35. In order to solve this, you need to make it say equals 0. So since we have x squared already on the left, we want to move 2x over by subtracting it. When you subtract it here, you need to subtract it on the other side. You can't take it away from x squared because they're not like terms. You simply write it as minus 2x. And you want to move plus 35 over by subtracting that one as well. So when you do it from the other side, again, not like terms, you'll have minus 35 equals 0. That's what we were trying to get. So you have everything equal to 0. What you want to do from there is factor out this trinomial into x times x, and then your factors of 35 and 1 and 35 and 5 and 7. 5 and 7 is a pair you want to use to get to b's value 2. This sign says they're opposite. This sign says the bigger one is negative. Negative 7 plus 5. And both of those are equal to 0. Now that you have it that far, you simply make x plus 5 equal to 0. When you subtract 5 on both sides, you get x equals negative 5 as one solution. And you do the same thing with the other one, x minus 7, this one, equals 0. When you add 7 to both sides, you get x equals 7. There's your other solution. Now, when it says extraneous solutions, you want to plug those numbers in and see if you get something that is incorrect. Sometimes you'll have to deal with that with negatives when you're talking about radicals. So let's look back at the original equation. It says x, so we'll use the first one, negative 5, equals the square root of 2 times x is negative 5 plus 35. So negative 5 equals the square root. 2 times negative 5 is negative 10, and 35 minus 10 is going to be the square root of 25. So this says negative 5 equals the square root of 25 is 5, but we also know that the square root of 25 is also negative 5. So that one checks out. We'll do the same thing with 7. 7, when you plug it in, equals the square root of 2 times 7 plus 35. 2 times 7 is 14 plus 35, which we know is 49. The square root of 49 is 7. Is the square root of 49 7? Yes, it is. It's also negative 7, so that one checks out as well. So there are no extraneous solutions in problem number 13. Both negative 5 and 7 are accurate. Solve by finding square roots. First thing you need to do is divide to cancel out this multiplication of 6. X squared equals 6 goes into 9 one time, 3 is left over, 6 goes into 36 6 times. So you have x squared equals 16. Take the square root of x squared to cancel it out, and it'll give you x equals the square root of 16 is both 4 and negative 4. Remember, you can write that as x equals plus or minus 4. Find C. Remember, in order to find C, take B divided by 2 and square it. B's value, it's in standard form, is 6. Divide that by 2, you know you get 3, and square that. Your C value is 9 for that one. Complete the square. So you need to complete the square by finding a new C value. 26 doesn't work. Subtract 26 on both sides. When you subtract 26 there, you have to do it here. X squared plus 12x plus C, our new C, equals 0 minus 26 is negative 26. So find your new C, just like we did on number 15. Take 12 divided by 2, you get 6, square that, and it'll be positive 36. If you add 36 to one side, though, in order to balance the equation, you have to add it to the other side. So negative 26 plus 36 is going to be positive 10. From there, you take this, what we have now is called a perfect trinomial. You take that perfect trinomial, and you take the square root of x squared, you get x. Take the square root of 36, you get 6. This is the sign that goes in between them, the one in front of b. So plus all of that perfect square, all that perfect trinomial is squared. So x plus 6 squared is 10. In order to solve the rest of this, we're going to get rid of the fact that this says x plus 6 squared. In order to cancel out squaring something, you take the square root of it. If you take the square root of the left side, you need to do it to the right side. It'll cancel it out. X plus 6 equals the square root of 10. From there, there's one more thing to do. Get rid of plus 6 by subtracting it. If you subtract it on the left, subtract it on the right. X equals negative 6 plus, or you can write it, if you want to get fancy, you can write it as plus or minus the square root of 10, because it can be both positive and negative. And we'll continue with part 2 on the next video.